What's up guys, this is Massey. Welcome to another video. In this video I want to talk about how to calculate and how to solve questions regarding half-life of a first order reaction. So I'm talking about half-life only for first order reaction in this video. So the time required for the reaction to reach half its original concentration is called the half-life of a reactant, and it is shown by T half. And as you saw in the video related to the first order reaction, we have after integration, that's the integrated form of first order reaction, ln A equals to negative KT plus ln A naught. A is the current or final concentration in terms of mole per liter. K is rate constant, which is depending on temperature. T is time. And we have ln A naught. A naught is the initial concentration. What we can do, we can just move it to the other side and keep negative KT in here. Then we multiply both sides by negative, so we end up having this. Then we rearrange it as ln A naught over A equals to KT. So when we are talking about half-life, it means that the final concentration is going to be half the original concentration. So A is going to be A naught divided by 2. So we sub it here. It's going to be ln A naught divided by A naught divided by 2 equals to K times T. In this case, T half, because we are talking about half-life time. So A naught divided by A naught divided by 2 is going to be ln 2 equals to K times T half. And T half is going to be ln 2 divided by K. And the value of ln 2 is 0.9693 divided by K. So let's see some example. Here it says a certain first order has a half-life time of 20 minutes. So T half is 20 minutes. Calculate the rate constant. So if we go back to the previous page, T half equals to 0.693 divided by K. So T half equals to 0.693 divided by K. So we can say K equals to 0.693 divided by T half. 0.693 divided by 20 minutes. That is going to give me 0.03465 per minute. That's going to be the K value. Part B. How much time is required for the reaction to be 75% complete? So 75% complete, it means that 75% of the original concentrations consumed. It means that only 25% is remaining. So A is going to be equal to 0.25 of A naught. So if I go back to the equation we had here, I'm going to say ln A naught divided by A equals to KT. So that's going to be ln A naught divided by 0.25 A naught equals to KT. So when you simplify it, it's going to be 1 over 0.25, which is going to be ln 4 equals to K times T. K, we already found the value for K, which is 0.03465. So T will be equal to ln 4 0.03465. That's going to be 1.38629 divided by 0.03465. That's going to make it to 40 minutes. So it means that after 40 minutes, it is going to be only 25%. And that makes sense. Why? Because the half-life is 20 minutes. So it means that after the first 20 minutes, the concentration changed from A naught to half of it. And for the second half-life, which is another 20 minutes, this half of A naught is going to be half again. So it's going to be 1 over 4 A naught. 1 over 4 is equivalent to 25%, which you saw it here, 75% consumed. It means that only 25% is remaining. Let's see another example. It says the rate constant K for the first order reaction is 0.0045 per second. What is the half-life time for this reaction? So since it's first order reaction, we need to write the formula again for half-life. T half equals to ln 2 over K, or 0.693 over K. So the K is given, we just need to find out the half-life time. So it's going to be 0.693 divided by 0.0045. That's going to be 154. What's the unit? It's going to be second. Why? Because here the K is per second. So these two, they have to be opposite units. If this one is minute, this one is going to be per minute. If this one is in second, this one is going to be per second. If time in terms of hours, this one has to be per hour. So the half-life time is going to be 154. It means that each and every 154 seconds, the reaction, the initial concentration is going to be half. Let's see another example. It says a certain reaction has the following general form. A of A gives B of B. At the particle temperature, the initial concentration is 2.00 times 10 to the power of negative 2 molar. Concentration versus time data were collected for this reaction, and the plot of ln A versus time resulted in a straight line with a slope value of negative 2.97 times 10 to the power of negative 2. What does that mean when it says the plot of ln A versus time resulting in a straight line? It means that we are dealing with a first order reaction. Why? As we saw it in this formula, we have ln A equals to negative KT plus ln A naught. I'm gonna rewrite it again. So ln A equals to negative KT plus ln A naught. So when we plotted this with respect to time, we're gonna have, if the reaction is first order, we're gonna have the straight line. If you compare it with the y-intercept form of linear equation, the slope must be negative K. So the slope is negative K. And here it says with the slope value of negative 2.97 times 10 to the power of negative 2 per minute. It means that K is 2.97 times 10 to the power of negative 2 per minute. So that's the rate constant. Part A, it asks us to find out the value of rate constant, which we saw it here. We can find it using the slope. Slope equals to negative K using this equation. It says calculate the half-life for this reaction. Again, the half-life equation for first order reaction is going to be 0.693 divided by K. 0.693 divided by K, 2.97 times 10 to the power of negative 2. That's going to be 23.33. What's the unit? The unit is going to be minute because the K is per minute. So the half-life time is 23.33 minutes. Next example. So here it says a certain first order reaction is 45% complete in 65 seconds. What are the values of the rate constant and the half-life time for this process. So we need to find out K. We also need to find out the T half. It means that 45% complete in 65 seconds. So it means that the remaining will be 55%. It means that A equals to 0.55 A naught. Now if we sub it in the formula, we have ln, we had it many times, A naught over A equals to K times T. So in this one, we know the relationship between these two, and the T is given, which is 65 seconds. So it's going to be ln A naught over 0.55 A naught equals to K times 65. That's going to be 1 divided by 0.55. 1.818. It's going to be 1.82, let's say, equals to K times 65. So K will be 65 divided by ln 1.82. That's going to be 108.5. It's going to be second. Why second? Per second? Because the time is in terms of second. So 108.5 is going to be the value of rate constant. So based on that, we can find out T half-life time, which is 0.693 divided by K. So it's going to be 0.693 divided by 108.5. So here I did a mistake here. So it's K equals to ln 1.82 divided by 65. So ln 1.82 divided by 65 is going to be 9.21 times 10 to the power of negative 3. So we have T half 0.693 divided by 9.21 times 10 to the power of negative 3. That's going to give me 75 seconds, which makes sense now. Why makes sense? Because it says after 65 seconds, 45% complete. We know in half-life, we're going to have 50% complete. So it means that that's a little bit smaller than half-life time, which the half-life time is 75 seconds. That's how I figured out there is something wrong before even reviewing what I did here. So you need to be very careful to check that if the number matches with what you have in the question. Let's see one more example. First order reaction is 75% complete, so it means that this time 320 is more than the half-life time. 75% complete in 320 seconds. What are the first and second half-lives for this reaction, and how long does it take for 90% completion? So let's start with part A. We said ln A naught over A equals to KT. So ln is A. 75% complete, it means that 25% remaining, so it's going to be 0.25 of A naught equals to K times T, which is 320. So it's going to be, when these two cancels out, 1 over 0.25, which is going to be ln 4 equals to K times 320. So K will be ln 4 divided by 320. That's going to be 0.0043. And the unit is going to be per second, because the time in terms of seconds here. Alright, so that's the K value. We need to find out the half-life time. .693 divided by K, which is 0.0043. That's gonna make it as 161 seconds. That's gonna be the half-life, or first half-life. Before I show you the second half-life, I want to show you something that without doing all this calculation, you can find out the half-life time. Whenever you have initial concentration, after half-life time, 50% of the reaction is going to be complete and the concentration drop to half of it. For another one is going to be not over 4. It means that only 25% remaining, 75% passed. So after 2 half-life, we're going to have 25%, which exactly what we had in here. So after 2 half-lives, we have 320 seconds. When you divide it by 2, you're going to get 160 seconds, which is very similar to this number here. That's how we find it without any calculation. So 320 seconds is going to be the second half-life. Now let's do the second part. It says, how long does it take for 90% completion? So we have ln, again we write this formula, KT. The final concentration is going to be 0.1 or 10% of the initial one, K times T. So it's going to be ln 10 equals to K times T. K we found it already, which is 0.0043 times time. So time is going to be ln 10 divided by 0.0043. 535.48. 535.8 seconds is going to be the time it takes to get to the 90%. So let's do it this way. 90% completion, it means that 10% remaining. A becomes 1 over 2A, then it becomes 1 over 4A, then it becomes 1 over 8A, then it becomes 1 over 16A. 1 divided by 8 it means that 12.5% remaining, and this one is going to be 6.25% remaining. So the final number must be close to that time. It means that one first half-life, second half-life, and third half-life. So 3 times 160 is going to be 480, but we're a little bit past the 12.5% because we are looking for 90% completion. So the number we have must be a little bit greater than 480 seconds, which makes sense because we got 535.8 seconds. So that's how we deal with half-life time in first order reaction. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.